Okay, so in part 3 of Introduction to Polynomials, we're going to look at the topic of combining like terms. And the polynomials that you're going to have in this lesson will be just one variable. The next lesson, the polynomial will be where we have more than one variable in the polynomials. But in this case, it's just one variable, so it's not going to be a very difficult lesson. It's fairly easy to deal with. All right, but again, in this lesson, we're going to simplify polynomials by combining like terms. Now, in a previous, well, okay, so the goal is to simplify polynomials by combining like terms. In a previous lesson you've had before, and you had to combine like terms when solving equations. So the idea of like terms is not foreign to you. It's something you've already dealt with. But recall in a previous lesson that like terms are terms that contain exactly the same variables raised to exactly the same power. So each variable is raised to the same power. All right, so here are some examples. So we're going to look at examples of like terms and then examples of unlike terms. All right, so the first example of a pair of like terms are these. Suppose it will be something like 5x squared, comma, negative 7x squared. Those are like terms. These two are like terms because they both contain the same variables. This term contains the variable x. This term contains the variable x. And the variable x are both being raised to the same power. They're both being raised to the second power. So that's an example of like terms. Another example of like terms would be these two, y, comma, 2y. So these two terms contain the same variables. This term contains the variable y, this term contains the variable y, and the variable y's are being raised to the same power, y to the first, y to the first. The coefficient has nothing to do with determining whether they're like terms. See, this coefficient's 5, this coefficient's negative 7. That has nothing to do with determining whether whether terms are like or unlike. You have to look at the variables in each term. All right, so then look at this other example of like terms would be something like 1/2 a squared b, comma, negative a squared b. All right, so those are examples of like terms. This term and this term both contain the variable a, and they both contain the variable b. The variable a's are raised to the same power, a squared, a squared. The variable b's are being raised to the same power, b to the first, b to the first. Again, the coefficient, 1/2, negative 1, has nothing to do with determining whether they're like terms or not. You need to look at the variables, make sure they both contain the same variables, raised to the same power. That's how you determine whether, that's how they would be like terms. Now, unlike terms, let's discuss some examples of unlike terms. So this pair of terms are unlike terms. So again, although they both contain the same coefficient, that has nothing to do with whether they're like or unlike terms. It has to do with the variable. This term contains the variable x. This does not. So right off the bat, they're not like terms. They both don't contain the same variables. All right, then let's look at this one. Negative 2x squared, comma, 5x. They both contain the same variable, all right, but the problem is this: the powers are not the same, the exponents are not the same. See, this variable x is raised to the second power, but this variable x is being raised to the first power, so they are not like terms. You cannot combine them, so they're not like terms. And then we have something like this: 6s, that's an s, t squared, comma, 4s squared t. Again, these two terms contain s's and they contain t's, but the issue is the exponent. This s is raised to the first power, this s is raised to the second. So right away you can say they're not like terms. Okay, now knowing what are like and unlike terms, remember we can only combine like terms. So knowing what are like and unlike, let's look at these examples. So each of these examples we're going to simplify the polynomial. And we're going to simplify the polynomial by combining like terms. Now remember the problems. The problems in this lesson will be the same variable. So in other words, if you look at the first example, the only variable you see is x. Nothing else. There's no x and y. It's just x. Okay. Now remember these are like terms. So 9x and a negative 20x. Now remember in a previous lesson we talked about determining what the terms are. So don't say this term's a 20. This term is a negative 20x. Okay? So when combining like terms, and these are like terms because this term has an x in the first, this term has an x in the first. When combining like terms, you're going to add their coefficients. So this coefficient is 9 plus, and this coefficient is negative 20. And you just got to figure out what the sum of the coefficients are. So 9 and negative 20 is a negative 11. So therefore what that means is that the answer to this problem right here, 9x minus 20x, would be a negative 11x. All right, so that's the answer. The next one, okay, letter B. These are like terms. These two terms are like terms because they both contain the variable x raised to the same power. So then we just add our coefficients. So this coefficient is 14 plus this coefficient is 9. 14 plus 9 is 23. So the answer then would be 23x cubed. So I have 14x cubed here. I have 9x cubed here. So altogether, I have 23x cubes. Over here, I have 9x's and then a negative 20x. Altogether, I have a negative 11x. Okay, letter C. So in letter C, you have this polynomial. All right, now notice that this polynomial, I'm going to go ahead and underline the like terms. So you have a 7x squared here and a 9x squared here. So those are like terms. And then don't forget about your constants. These are constants. Remember that you're the word constants. These are constant terms. These two. So I can combine, remember you can combine like terms. So these are like terms and these are like terms. So let's put these in descending order. Remember the word descending order. And remember when there's, and it's not incorrect, but when writing the answer, when writing the answer as a polynomial, we tend to put the constant last. So if there's only one variable, we tend to put it in descending order from largest exponent to smallest. Remember, largest exponent to smallest. Largest exponent to smallest. Okay, so let's do the x squareds first. So 7x squared plus 9x squared. So 7 plus 9 is 16. So I'm going to have 16x squared. So I'm going to have 16x squared. All right, and then 3 plus a negative 10 is a negative 7. Okay, so I'm going to write this as 16x squared minus 7. So that's how you want to write it. Okay, so we prefer this. If you said 16x squared plus a negative 7, there's nothing wrong with that, but this is what we prefer. So remember, adding a negative 7 means the same thing as subtracting 7, so that's how we want to write it. You want to write it like this. Okay, so this is how we write it. Letter D. So letter D, remember I'm going to underline, I'm going to, since I have more than like terms here, more than one pair of like terms, I'm going to underline my like terms. So these two are like terms. They both contain the variable x raised to the same power. This is a constant term, and there's only one of them. So these are the only like terms right here. So I'm going to say 15 plus a negative 3 is a positive 12. 15 plus a negative 2 is a positive 12. And if you don't remember your signs, just use your calculator. So therefore, 15x squared and a negative 3x squared is a positive 12x squared. And then the only thing left is this minus 13. So subtract 13. Okay, so there's your answer there. That's how we want to write it. Remember, descending order from largest exponent to smallest exponent. So remember we talked about degrees. Let's review the idea of the degree. So the degree of this term is 2. Remember the exponent. The degree of this term, remember that's a constant. The degree of a constant is 0. The degree of a constant is 0. Letter E. So these three terms, there are three terms here, and they're all alike. S to the first, S to the first, S to the first. So I just add their coefficients. So I have 8 plus a negative 5 plus a positive 4. 8 plus a negative 5. The coefficient of this term is a negative 5, and the coefficient of this term is a positive 4. So if you don't remember anything about adding signed numbers, just use your calculator. But 8 plus a negative 5 is 3, and 3 plus 4 is 7. So 8 s's and a negative 5 s's and a positive 4 s's is a 7s. So there's your answer. So your answer is just one term. It's still a polynomial. A polynomial is one or more terms. It has to be in a certain, the term has to look a certain way though, but this is a polynomial, one term. It's a monomial. So that's a binomial, that's a binomial, that's a monomial. Letter F. Okay, so letter F, and again, let's put this in descending order. So I'm going to go straight to the one that has the largest degree, the largest exponent. So x to the 5th, here's another term that's alike. So these two are like terms. Then I have the x cubed, so I'm going to line those twice. So those are like terms. And then the constant. And there's only one term that's a constant. All right, so let's put this in descending order. So I'm going to add the x to the 5ths first. All right, so remember, be careful. You gotta remember your signed numbers. So use your calculator if you need to. So this coefficient is a negative 2 plus, and this coefficient is 7, and negative 2 plus 7 is 5. So what that means then is this. A negative 2x to the 5th and a positive 7x to the 5th is a 5x to the 5th. All right, now the x cubes. This coefficient is 7, and this coefficient is a negative 10. 7 and negative 10 is a negative 3. So what that means is that 7x cubed and a negative 10x cubed is a negative 3x cubed. Okay, but remember, we tend to write it as 5x to the 5th minus 3x cubed. And then the only thing we have left is this constant, so just say plus 6. So there's your answer, descending order. This degree is 5, this degree is 3, this degree is 0. Always write your constant term last. Letter G. Now in letter G, I'm going to go ahead and use the calculator since those are dealing with decimals. It's quicker just use the calculator here. Again, it's always best if you need to underline your like terms. So here's y squared, and here's another y squared. So those terms are alike. And then I have my constant terms. So I have two terms that are constants, and so they're like terms. All constant terms are like terms. All right, so let's add the decimals using the calculator. Remember how to use your calculator. All right, so remember 0.1, oops, so 0.1 plus, and this coefficient's a negative 1.2. So I'm going to say negative. Make sure you use the correct button here. So you use this right here for negative. So negative, notice how it shows up, negative 1.2, and then press enter, and so I get negative 1.1. So 0.1y squared and a negative 1.2y squared is a negative 1.1y squared. Okay, now your constant. Go ahead and clear this. So 6.7, a positive 6.7, plus a negative 1.9, equal, and then positive 4.8. So I get negative 1.1y squared plus 4.8. And that's it. It's in descending order, from largest exponent to smallest. All right, let's look at the next one. Okay, so the if they're decimals, just use your calculators. So it's much quicker to use your calculator. All right, Now, this time we have fractions, but again, use your calculator. Now, I'm going to remind you how to add fractions if you forget your calculator, but if you have access to calculator, use your calculator. All right, now, so again, if you need to, underline your like terms. So I have this term x to the fourth and this term x to the fourth. So those are like terms. This coefficient is 2/3, this coefficient is 1/6. All right, now let's look at the cubes. These two, I'm aligning them twice, so those are like terms. And then your constant. I only have one constant. All right, so let's put this in descending order. So we're going to start x to the fourth. Now, use your calculator if you need to. So you're going to say 2/3. So you can say 2 divided by 3 plus, and then this coefficient's 1/6. So you're going to say 1 divided by, positive 1/6. So 1 divided by 6, and then press equal. Now remember, you get this decimal here. There's no way that you can, maybe a few of you, but for the most part, you're not going to know what fraction this decimal represents, this rational number represents. So use your calculator. So remember, we're in second, PRB, and then see you're going from decimal to fraction, fraction to decimal. Press enter, and you get this fraction 5/6. So 2/3 plus 1/6 is 5/6. So I'm going to write the answer as, so far the answer is 5/6 x to the fourth. All right, so that's what I got so far. Now your x cubes, now these are just integers, so I'm just going to go ahead and do this. 12 plus, and this is a negative 19. 12 plus a negative 19 is a negative 7. And so therefore I get 5/6 x to the fourth minus 7x cubed, and then the only thing left is this constant, minus 19. Okay? All right, now what I want to do is just to remind you how to add fractions, because I'm sure that for some of you, you forgot how to do this without using a calculator. So remember, we had 2/3 plus 1/6, and that's what I was adding. And I used a calculator for this, and that's how I got this 5/6. So remember, when adding fractions, your partitions have to be the same. So meaning that your denominators have to be the same. Now, it doesn't matter whether you use any common denominator, does not matter, as long as your denominators are the same. It could be a common denominators, but we tend to use the least. If you use the least, it makes the numbers easier to deal with. So let's use the least common denominator, so the LCD. So this denominator is at 3, this denominator is at 6, and so the question is, what's the smallest number, so the least, what's the smallest number that 3 and 6 go into evenly? All right, so if you say 12, 12 goes in, 3 goes into 12, 6 goes into 12. If you say 18, 3 goes into 18, 6 goes into 18, but that's not the least. Those are common denominators, and you could use them, but let's use the least. So the smallest number that 3 goes into and 6 goes into is 6. All right, 6. So that's the least common denominator. 3 goes into 6 2 times, 6 goes into 6 1 time. Okay, so once you find the least, then you're going to write equivalent fractions. Remember the word equivalent fractions. All right, equivalent fractions. And so basically you're going to write two fractions. Since I have two fractions here, I'm going to write two fractions here. I want this denominator, both denominators to be 6. And so when I say I'm writing equivalent fractions, the question is 2/3 is equivalent to what number divided by 6? 1/6 is equivalent to what number divided by 6? That's what I mean by writing equivalent fractions. Okay, and so what we did was this. This denominator is a 3, but I want it to be a 6. So in order to get a 6 there, I've got to multiply this 3 by 2, and that's how I get the 6. But remember, what I do to the denominator, I have to do to the numerator. So 2 times 2 is 4. And it kind of makes sense because 4, 6, when I reduce it, they're both even, divisible by 2. If I divide both numerator and denominator by 2, I get 2/3. 4 divided by 2 is 2. 6 divided by 2 is 3. All right, so 2/3 is equivalent to 4/6. All right, over here, the denominators are the same. And so if you need to say times some number, then just do it. So this will be 6 times 1 is 6. 1 times 1 is still 1. All right? But basically, whenever the denominators are the same, the numerators have to be the same. And so therefore, since the denominators are the same, I have 4/6 of something and then another 1/6 of something. So when I combine them, I get 5/6. So 5/6. The question is, if I have 4/6 here and then 1/6 here, then altogether I have how many 6? The question is 5, or the answer is 5 of them. And so that's how you get this 5/6 right here. Okay. Now let's look at letter J, letter I rather. All right, so again, I'm going to underline my like terms. So let's see, the largest is 3. So actually this term, there are no other like terms with it. Let me make sure I wrote this correctly. Yeah, okay. And then, so when I write the polynomial in descending order, I'm going to right away put 3/20 x cubed first. Okay, so I can combine it with nothing else. There's no other x cubed listed. Then the next is x squared. All right, x squared. So there's no other listed, so I'm just going to say plus x squared, 6x squared. All right, now I do have, for x, I do have this one and this one. All right, so use your calculator. Now be careful, don't say this is 3/10. Otherwise you're going to get a wrong answer here. So you got to remember from a previous lesson that the coefficient of this term is a negative 3/10. So this term is negative 3/10 x. So the coefficient is a negative 3/10. All right, so you can say negative. So negative 3 divided by 10 plus a negative 7/20 plus a negative, see the negative, plus a negative 7/20. 7 divided by 20. Then press equal, and you get this decimal. All right, now that's easy to see what it is. That's a negative 65 hundredths, but let's reduce it. So just use your calculator. So second PRB, press equal, and then it reduces it for you. So negative 13/20. So this will become minus 13/20 x. That's what that becomes. All right, and then your constant, 1/10 and a negative 1/5. Those are your constants. So you say 1 divided by 10 plus, and then that is a negative 1 divided by 5. Oops, I forgot the negative. So negative 1 divided by 5, press equal, and you get this decimal, negative 1/10. All right. So don't write it as negative 0.1, because remember, if the coefficients were fractions, you want your answer listed as fractions. So don't put a decimal here. So you have a calculator. You know what this is. Use your calculator. So negative 0.1. Now in the previous course, that was easy to determine what fraction this is, because that's 0.1, which is 1/10. In this case, negative 1/10. If you don't remember, just use your calculator. Second PRB, press equal. Oops, I'm sorry. Press equal, and you get negative 1/10. So this would be minus 1/10. And there's your answer. So you wrote in descending order. This degree is 3, this degree is 2, this degree is 1, this degree is 0. Okay? All right, letter J. Let's look at letter J. All right, so letter J, we're going to do the same thing. We're going to underline our like terms. So we have an x cubed and we have another x cubed. All right, so use your calculator. You're going to say 5/6. So 5 divided by 6 plus, this coefficient is not 1/5. This coefficient is a negative 1/5. This term here is a negative 1/5 x cubed. So that coefficient is a negative 1/5. So you can say plus a negative 1 divided by 5, press equal. So there's a decimal. So change it to a fraction. So that's second PRB. Press equal, and you get 19/30. Positive 19/30. So 5/6 x cubed and a negative 1/5 x cubed is a positive 19/30. So 19/30 x cubed. Okay? All right, now let's see. The next term will be the x. So we have a negative 3/4 x and a positive 7/12 x. So negative 3 divided by 4 plus a positive 7/12. So 7 divided by 12, press equal, and we get this decimal. Second PRB, press equal, and we get negative 1/6. So I'm going to have 9/30 x cubed minus 1/6 x. And then the only thing left, the only term here is this constant, so I'm going to say plus 6. Okay? All right, and again, just let's remind ourselves how to add these fractions if we don't have access to a calculator. So remember, what we did was this. What we did was we said 5/6 plus, and this is 5/6, and this is negative 1/5. So 5/6 plus a negative 1/5. So again, what we did was we found the LCD. So the LCD here, the smallest number that 6 and 5 go into is 30. That's the smallest number, so that's the least. Now there's an infinite number of common denominators, so let's just use the least though. Let's use the smallest. So I'm going to write equivalent fractions with that denominator. And so I'm going to ask myself, 5/6 is equivalent to what number divided by 30? So 6 times 5 is 30. What I do to the denominator, I have to do to the numerator. 5 times 5 is 25. And it makes sense that these two fractions are equivalent because 25/30 is divisible by 5. And so when I reduce it, I do get 5/6 back. Okay, over here, 5 times 6 is 30. Negative 1 times 6 is a negative 6. And so now I just add their numerators. So I get 25 and a negative 6 is a positive 19, and then 30ths. Okay? All right. Now, so that takes care of J. Okay, now the other type of example you'll see is this. So let's kind of talk about this. Okay, so on my math lab, they're gonna say write a polynomial that describes the total area of the following set of rectangles. All right, and then simplify the polynomial. All right, so remember the area of a rectangle or square is length times width. Length times width. So basically, for example, over here, this area, so this is 5 feet or 5 inches, whatever the units are. It doesn't matter in this case. Whatever the units are, you're going to say the area of this rectangle will be 5 times 3, which is 15. So this is I'm going to just write it right here. So that's 15. All right. Now, remember, that's the area. So this is the area of this rectangle. And so let's start over here. So 3x, length times width, or you can say this is length, this is width, does not matter. So length times width. So 3x times 3x, so 3 times 3 is 9. I should have left some room here, but let me just do this. So that's 9 right here. And then x times x is x squared. So this area is 9x squared. Here, 6 times x, so this area is 6x. Remember, what I have circled is area. Here, x times x is x squared. So I'm circling, that's the area. The area here, 4 times x is 4x. And then here, 6 times 2 is 12. And then 12. And then here, the area was 15. Okay? All right, now here's how you can write the answer. So the question was this. The question is, write a polynomial that describes the total area. So basically, you're going to say this. First of all, you're going to say this. You're answering this part first. This first part. And then you're going to simplify. All right, so the first part says this. This is how you're going to write it. You're going to just go through each rectangle. You can list the terms. So you're going to say 9x squared plus 6x plus x squared plus 4x plus 12 plus 15. Okay? So that's the first part. So you wrote all these rectangles as areas. And we're going to add them up though. Okay, then you'll say comma, and now you're going to simplify. So let's combine like terms. Basically, remember, you simplify polynomial, you're combining like terms. So 9x squared and 1, remember there's no number there, so this will be 1, so this will be positive 1. So 9x squared and 1x squared is 10x squared. All right, now the x, 6x and 4x is 10x. And then 12, your constants now, 12 and 15 is 27. Okay? So here's your polynomial, and then here's the simplified polynomial. All right. So the example 2 dealt with finding the area. So remember, area is length times width. So 3x times 3x is 9x squared. 6 times x is 6x, and so on. X times x is x squared. And so here, since, look, there's 1, 2, 3, 4, 5, 6. So I have 6 terms. 1, 2, 3, 4, 5, 6, and then you combine them. All right, the final example has to do with perimeter. So it says, write the perimeter as a polynomial. So remember, perimeter of a figure is the distance around the figure. Right, so the distance around the figure. So basically, if you look at this figure has, let's count the sides though. There's 1, 2, 3, 4, 5, 6, 7, 8 sides. There are 8 sides. So again, 1, 2. So it's kind of like if you walked along a path. So you have this straight path, you have this straight path, this straight path, this, this, and then this. Okay? All right, so again, just like you did earlier, you're going to write the polynomials. It does not matter where you start. It does not matter. We're just going to start at the top side. So I'm going to say 5x, and I'm going to go clockwise. So 5x plus 3, that's an x, plus 4x, plus 3, plus 2x, plus 6, plus 3x, plus 7x. And then we're going to simplify. So let's combine like terms. All right, so 5 and 4 is 9. All right, so and then 9 and this 2 is 11. So remember, I'm combining like terms. So these are like terms right here. Remember, to combine like terms, you're going to add our coefficients. So 5 and 4 is 9. 9 plus 2 is 11. 11 plus 3 is 14. And then 14 plus 7 is 21. So I get 21x. Now your constants, 3 and 3 is 6. 6 and 6 is 12. So I get 21x plus 12. Okay? So remember, perimeter is the distance around the figure. So you're adding all the lengths together. And then you just combine like terms. All right, so that takes care of part 3 of Introduction to Polynomials.